faithfully conveying value, interpreting great books from around the world. Hello, this is Sally's Book Talk. Today, the book we're exploring for you is Which Star? Not on the Star Chart, with the subtitle Searching for the Boundaries of the Solar System. When it comes to the solar system, even elementary school kids can list the 8 planets. But do you know how these planets were discovered? Why wasn't Uranus discovered until the 18th century? Why is Neptune called a planet found at the tip of a pen? Why did Pluto fall from its planetary throne? All these fascinating questions can be answered in this book. Although this is an astronomy popular science book, it focuses on history. You can think of it as the stories of the solar system in astronomy. The author of this book, Chan-Hai Liu, is a physics popular science writer and software engineer. He was a top student in Fudan University's physics department. As a junior, he outperformed physics graduate students and was admitted to Columbia University with the highest score. While pursuing his PhD in physics, this top scholar set aside complex physics concepts and equations, using vivid and humorous language to take us on a deep tour of the solar system. Now, let's explore the boundaries of the solar system by following the discovery stories of Uranus, Neptune, and Pluto. In ancient times, people gazing at the stars noticed something. In the vast night sky, most stars seemed fixed, while some moved to different positions, shuttling like celestial messengers. People discovered 5 such wandering stars and named them planets. The English name planet comes from Greek, meaning wanderer. These 5 stars are the familiar metal, wood, water, fire, and earth stars, plus Earth dash making 6 planets. This number remained unchanged for millennia, even considered eternal truth, until March 13th, 1781, when a new planet was discovered. This discovery ushered observational astronomy into a brand new era. From then on, humanity began the long journey to map the solar system's boundaries, and our story starts here. The first person in millennia to discover a new planet was Herschel, who remarkably was a musician. Herschel was born into a musical family in England. By age 14, he was already performing on stage and had composed dozens of symphonies and concertos. This young musician, eager to understand the mathematical principles of harmony, delved into math. But through math, he encountered optics. And through optics, he got interested in astronomy, eventually becoming an amateur astronomer. Herschel demonstrated what true capability means. Don't dismiss it as just an amateur hobby. It was precisely this hobby that led to his greatest discovery in life. In the early 18th century, Newton, Halley, Lagrange, and others built a magnificent system of mechanics. Professional astronomers were immersed in it, obsessed with calculating orbits of known celestial bodies. Astronomy became focused on confirmatory calculations rather than exploratory observations. Because Herschel was self-taught and didn't grasp all those complex calculations, he was able to pioneer new frontiers in observation. Herschel, passionate about observation, made hundreds of telescopes in his lifetime. He turned his house into a telescope factory. One telescope, 12 meters long, extended from the house like a cannon into the sky, becoming a local wonder. Herschel was like a man possessed every day, gazing through the cannon to the point of forgetting to eat and sleep. His sister had to feed him bite by bite, and he only slept when bad weather forced him to. After 3 years of such observation, he finally discovered a new celestial body with a slightly round disk. When he increased the telescope's magnification, the object's disk enlarged proportionally, which proved it wasn't a star. Because stars emit their own light, no matter how high the magnification, they appear only as points of light, not as disks. And it was a new planet named Uranus. The discovery brought Herschel great honor. People were astonished to find that Uranus is a planet visible to the naked eye. In astronomy, the concept of apparent magnitude is used to represent a star's brightness. The smaller the number, the brighter the star. The brightest stars are first magnitude. Sixth magnitude is the faintest visible to the naked eye, and Uranus can reach magnitude 5.5. Yet such a star had slipped past people's notice for millennia. Looking back at historical astronomical records, Uranus had been recorded at least 22 times before its discovery. The earliest instance dates back nearly a century ago. Unfortunately, all 22 astronomers who made these records mistakenly thought it was a star. The most pitiable among them is a French astronomer. She recorded Uranus's position 8 times in just 20 days. Logically, such intensive records should have revealed Uranus's planetary motion. But fate played a cruel joke. What happened? You might have heard of Mercury retrograde, meaning Mercury appears to move backward. Retrograde motion occurs because planets orbit the sun at different speeds than Earth. Sometimes it looks like it's moving backward, just like cars beside a speeding train appear to be reversing. Actually, retrograde isn't unique to Mercury. Uranus also experiences it. And when transitioning from retrograde to direct motion, there's a brief period where it appears almost stationary. What this French scientist never expected was that his 8 intensive recordings happened exactly during this stationary period. It was this coincidence that caused him to forfeit the honor of discovering Uranus to Herschel. That's the story of Uranus's discovery. The discovery of Uranus shattered the myth that the solar system's planet count was eternally fixed. In the solar system, how many other planets like Uranus, hidden in plain sight, are out there? People are itching to solve this puzzle, but with the vast, starry sea, must they cast a wide net like Herschel again? Just stumble upon it by luck? Of course not. Planetary orbits mostly lie near the ecliptic plane, Earth's orbital plane, and they follow a pattern. A formula calculates planetary orbital radii with one key variable. Min is the planet's number. For example, Earth is 1, Mars is 2, Jupiter is 4, Saturn is 5, and calculations match its actual orbit perfectly. You've probably noticed the problem between Mars and Jupiter. Number 3 is missing. How could nature leave such an obvious gap? This strange gap seems to await an undiscovered planet. This got everyone fired up. Astronomers across Europe became talent scouts overnight, dividing the sky into sections, each searching their own patch. One Italian astronomer determined coordinates for over 670 stars, checking each one individually. This grueling labor lasted 11 years. Finally, he discovered a moving star, but lost track of it near the sun. At this critical moment, the prince of mathematics, German mathematician Gauss, stepped in to help. Like Michael Jackson performing free at a small country bar, using just 1 month's observational data, he calculated the new celestial body's orbit. Astronomers were ecstatic, finally capturing this star named Ceres. Ceres' astronomical radius perfectly matched the mathematical formula. It seemed they'd finally found the new planet between Mars and Jupiter. But hold on, just 3 months after Ceres' discovery, another star appeared in the same orbit, named Pallas, meaning wisdom. Now there was trouble. One orbit crammed with 2 planets. If Ceres brought joy, Pallas's appearance was downright awkward. Amid the confusion, veteran astronomer Herschel declared, "Neither qualifies as planets. They're smaller than the moon. Call them asteroids." Initially, people thought Herschel was raining on their parade, trying to elevate his Uranus discovery by belittling others' finds. But 2 years later, another celestial body appeared in that orbit, Juno, goddess of marriage. Meaning marriage, now things were really heating up. Between Mars and Jupiter, 3 celestial bodies now vied for planetary status. So people accepted Herschel's advice, demoting all these little ones to asteroids. Later observations revealed thousands of asteroids between Mars and Jupiter, forming a belt that filled the n=3 gap. With no room inside, they looked outward. Everyone focused beyond Uranus's orbit. At the n=7 position, they found traces of planetary activity. The clue? Uranus kept deviating. Despite more data and better algorithms, its calculated orbit never matched observations, making people doubt Newton's law of universal gravitation. After exhausting all hypotheses, only one remained standing. Beyond Uranus's orbit, there exists another large planet. Its gravitational pull disturbed Uranus's orbit, and now comes the climax of the story. So, where exactly do we look for this unknown new planet? It can be predicted that it's twice as far from the sun as Uranus and moves much slower. Searching by observation is almost impossible. So, the only way forward is through pure mathematical calculation. But this kind of calculation is extraordinarily difficult. In an era without computers, it was a dauntingly massive undertaking. But fortunately, geniuses emerged in astronomy, and two appeared at once. The first was Adams from England. In 1841, 22-year-old Adams was a student at Cambridge University, deeply captivated by the problem of finding a new planet. After dedicated research, he finally calculated the orbit of the unknown planet in 1845. So Adams took his calculations to visit Airy, head of the Greenwich Observatory in England, but Airy was either away at meetings uh, or out for lunch, and Adams was turned away 3 times. So Adams left his calculations behind and returned to Cambridge. Airy did see the results, but he didn't take this young fellow seriously, acting quite coldly. He sent a reply, brushed it off with a few words, and shelved Adams' calculations. Airy's disdain left Adams deeply disappointed, and it later became a great regret for British astronomy. So, just as opportunity slipped through the British fingers, the French also turned their gaze to the new celestial body. The second to perform the calculation was Leverrier from France, who was 8 years older than Adams. In 1846, he also calculated the position of the new planet. The wisdom of these two mathematical masters on either side of the English Channel pointed to the sky, the same position, but neither knew of the other's work. Leverrier didn't politely visit his elders like Adams did. Instead, he published his calculations publicly. Now, upon hearing this, Director Airy couldn't sit still. He dug out Adams's calculations. Wow, the results are practically identical. At this time, the French astronomy community was still skeptical about Leverrier's calculations and remained on the fence. But only Airy knew in his heart that with Adams' calculations as backup, the result was quite reliable. Such a big deal had been shelved under his nose for over a year. Airy knew he couldn't dawdle. He had to seize the opportunity before the French caught on. The fate of British astronomy hung in the balance. Director Airy assigned the observation task to the Cambridge Observatory, but the pace at which Director Charles started was maddeningly slow. It took a whole month to begin observations because it was a last-minute overtime job. Charles didn't take it seriously, and the work was tedious, comparing tons of data daily. One day, he compared 39 sets of data without spotting anything odd. Even with some left, he figured there'd be no more discoveries that day. Thinking of other unfinished tasks, he quit early, a critical blunder that cost everything. He didn't know that just 10 more sets would reveal a celestial body not seen before, the exact new planet Airy had tasked him to find. The British repeatedly missed chances in this invisible race, and history's tide turned toward Europe. While Charles searched, Leverrier did new calculations, using over 10,000 pages to confirm his work. Bolstered, he sought observatory observations, but major observatories knew the workload was huge and politely refused. Leverrier's requests hit walls everywhere. Then Leverrier suddenly recalled a fan named Gally, an assistant at Berlin Observatory in Germany. So he wrote a letter to Gall. The letter arrived on September 23rd, 1846, saying, "Just point the telescope about 5 degrees east of Delta Capricorni on September 23rd evening to find a new planet." Gally was stunned. It felt like a letter from God. with timing so perfect it seemed planned. That very day was September 23rd, and Galley was deeply captivated by this prophecy. That night, he took a student and began observing. Galley peered through the telescope while the student checked the star chart, comparing each one meticulously. Just half an hour passed, and the thrilling moment finally arrived when Galley observed a faint celestial body with an apparent magnitude of 8, less than 1 degree from Leverrier's predicted position. The student holding the star chart shouted, "That star isn't on the chart!" This star not on the chart was Neptune. At that moment, a celestial mechanics legend was born. It was Newtonian mechanics' most glorious day. Merely through the motion of known planets, they indirectly calculated the orbit of an unknown planet billions of kilometers away, with no observational data. This was an unprecedented feat. Instantly, everyone was stunned by this dazzling achievement. Even the King of France was awed by Leverrier's fame. Leverrier, discovering Neptune with a pen, became an astronomy legend. At this point, Airy and Charles, the two observatory directors, were bitterly regretful. If they hadn't missed their chances, one after another, such glory would have had nothing to do with the French. However, Adams himself, indifferent to fame, didn't defend himself. He devoted his energy to calculating Neptune's true orbit using data, and his paper won widespread acclaim. People even thought his calculation method was more elegant than Leverrier's. And Adams formed a lifelong friendship with Leverrier, and they shared the credit for discovering Neptune. The relay discovery by Britain, France, and Germany made Neptune's story a beautiful tale in astronomical history. The discovery of Neptune greatly stimulated astronomers' and mathematicians' interest. That a star could be found with paper and pen made mathematical searches for new planets fashionable. Because Neptune's discovery was so intoxicating, astronomers began eagerly hoping for another planet to misbehave, because only then could they recreate the glory of discovering Neptune. So people began nitpicking, becoming suspicious. They not only thought Uranus was still misbehaving, but also suspected Neptune was irregular, convinced another unknown planet affected their motions. Actually, Uranus and Neptune's observational data fully matched theoretical calculations within acceptable error margins. Yet, some stubbornly charged ahead, determined to find trans-Neptunian planets through these negligible errors. American astronomer Lowell was one such person. Using Leverrier's method, he calculated a new planet beyond Neptune, about 6.6 times Earth's mass, disrupting Uranus and Neptune's motions. He devoted his final years to searching for this new planet, but died with regret. Little did he know, his last 5 years of photographic plates quietly held images of an unknown celestial body. Truly, fate brings destined souls together across miles, while others miss connections face to face. After his death, the search passed to a 22-year-old farm boy. This youth, Toumba, an assistant at Lowell Observatory, used Lowell's calculations. After a year of tedious observations, he discovered Pluto in 1930, just 6 degrees off predictions. Celestial mechanics seemed glorious again, with posthumous honors for Lowell. Then people eagerly began measuring this new planet. But measurements revealed Pluto's mass was wildly overestimated. Not 6.6 times Earth's, but lighter than the Moon. At 0.2% of Earth's mass, its gravitational effect was weaker than distant Earth's. This dealt a crushing blow to Lowell's predictions about Pluto. It wasn't a Neptune redux, just pure coincidence. Lowell's calculations were entirely wrong, yet this flawed prediction accidentally bore beautiful fruit. By then, 9 planets had been discovered, but astronomers soon found Haumea, Makemake, Eris, and others near Pluto's orbit. These Pluto-sized objects, some larger, raised questions: should they be planets too? As this debate emerged, a more fundamental question surfaced. What exactly is a planet? Remember how we talked about Ceres, Pallas, and Juno being demoted to asteroids? It's because they committed two serious crimes. One is being too small, and the other is illegal congregation. Now, Pluto has committed the same crimes. Forget its size. Its surface area isn't even as big as Russia. But let's talk about illegal congregation. Pluto is in a region called the Kuiper Belt, which is packed with thousands of small celestial bodies. Altogether, their mass is only about 1/10 of Earth's. Pluto was just the first Kuiper Belt object found. If all of them could be called planets, the 9 planets would become hundreds or even thousands. To define it, the astronomy community created a definition for solar system planets with 4 parts. First, we all know a planet must orbit a star and can't be a satellite. Second, a planet can't be too big. Its mass, upper limit, is about 13 times Jupiter's. Any bigger, and nuclear fusion turns it into a star. Third, it can't be too small. Its diameter must be at least 400 kilometers, so gravity shapes it into a nice sphere. Asteroids are too small, failing the looks test, mostly shaped like potatoes. Fourth, a planet must clear its orbital neighborhood, meaning it must dominate its own orbit. It was this crucial fourth point that caused Pluto, on the planetary throne for 76 years, to be kicked out overnight and demoted to a dwarf planet, meaning it's underdeveloped. Dwarf planets are like the middle class, better than asteroids but not full planets. Like Makemake, Haumea, and Eris, they're all dwarf planets with Pluto, mainly because they can't clear their orbits. Now, let's recap humanity's long journey in searching for the solar system's boundaries. So, from the 5 classical planets, metal, wood, water, fire, earth, to modern Uranus and Neptune, to today's Kuiper Belt with Pluto, humanity has mapped the solar system. Over the past 200 years, it has expanded about tenfold. So, is the Kuiper Belt where Pluto resides the boundary of the solar system? The answer is no. The Kuiper Belt is more like the solar system's suburban outskirts. Beyond it lies another ring called the scattered disk, composed of icy asteroids. The scattered disk isn't the farthest region. Scientists propose that even farther out, there's a spherical cloud enveloping the solar system, filled with comets. This cloud is called the Oort Cloud, extending to the edge of the sun's gravitational influence, perhaps the true solar system boundary. Vast as it is, even the solar system has limits. But humanity's instinct to explore the unknown knows no boundaries. That concludes our interpretation of that star is not on the star chart for you. Reading notes are below the audio. See you tomorrow.